Hey YouTube, welcome to our channel, the ultimate channel. I just sometimes lose word. The ultimate channel to crack your software and reviews. If you are new here, make sure to subscribe and hit the notification bell so you will never miss a video. And sorry for this introduction. And okay, let's start in the code. We have this one. It's problem number 108. Convert sorted array to binary search tree. So given an integer array nums where the elements are sorted in ascending order, that's good. Convert it to a high balance binary search tree. So basically I can just put everything and just put in the left, and that's it. It should be high balance. So for example, we have this array and we returning this just 0. It's left, the left, as we know. We'll describe everything actually in a moment. And okay, so basically we have this array, and we start by defining the root and defining its left side and its right side, or maybe its right side, its left side. We will see how we can do it. So to solve this problem, let's just go here. This is from my last one. Okay, so let's say that we have a tree, an array that is sorted. It just will be minus. I just want something different. Okay. Okay. Okay, so basically we have this array. And we want to create a binary search tree. So basically, what is a binary search tree? That when we have a root, and each thing on its root left, it's smaller than the root, and in the right is bigger than the actual node. Let's say this is a node. It's bigger than the node, and it's high balance, so the right side should be similar to the left side. And yeah, that's it. So basically, let's see how we can solve this problem. What is the ways? Basically, we can use, I guess, we can use a depth first, I guess. No, it will not be depth first. We could use a depth first, DFS. Sorry for that. We'll use a depth first, and basically what that means, that we will start by the innermost element and try from it to try to build up its right, its left. And we have three solutions. We have a preorder, pre-order, and in order, and post order. Post order. Okay, so basically in these there are three ways basically to solve this problem: by the depth first, and wait a minute, depths first. Sorry for that. Depths first. Okay, depths first. So basically, with the three these are the three solutions. I will go into a high level into all of the three solutions, and after that we only pick one to use. And don't worry, I will create additional 2 videos for the other solutions. So basically, we start with the preorder. For the preorder, let's just start only with the preorder. I will not say what is in order is and what is post order is. So basically we will only focus on pre-order. So in the pre-order, what we are going to do, basically in the pre-order, we start with the root. After that we go to the left side, and after that we go to the right side. So for this example, the root was 0, so we start to find 0, and wait a minute, zeros, okay, and we'll start with the left side, so it will be -3, and again -10. And because it's a sorted array, I can just take the node in the middle and just say this is the root. That's it, because it's a sorted array. And I will say that the right side will be, yep, okay, the right side will be 9 and 5. And yeah, that's it basically. And something that and that's it basically. We identify the left. After that we go with the right. So let's put that in code, and of course we will use recursion. Maybe we could, yeah, we will use recursion. It's, I guess that the last 3 videos also we used recursion. For this video also we use recursion. We have tons of recursions. Okay, so basically we'll start to have a sorted array. We have nums. I would say that we are using recursion. What we should do each time when we have a recursion, yes, that's right, we are getting our base code. So basically our base case. So basically we create a function called helper, and this function takes left and right and do something with this, right? This is our recursion function that we will call this function over and over. And we will say return helper of 0 and nums dot length -1, because basically this is the left is 0. This is, let's just put this one here. The left is this one, and the right is 9. So I'm saying the base case, this is the recursive function. We should find the base case. So the base case, it will be if left bigger than right, return null. Because this is the left. The left shouldn't be bigger than right at all. We stop once we find that. So I will say that first const, we create a pointer equals math dot flow, and basically it will equals left plus right. We can call it mid, basically. Let's just call it mid. Left plus right multiplied by 2. Okay. Or we can call it pointer, just like it doesn't matter basically. And we have const root, and the root will equals, okay, so we have to look at this one. We have a data structure. We have an object called tree node, and it has left and right as a value. It has left and right, and it has a value. So we create something called root, and it will be new tree node, and we will give it nums of mid. Okay, and we will do something like that. Root dot left equals helper of left mid -1, and root dot right equals root mid +1 with right and we return this root. Oh, what? It's mid minus 1, I guess. Okay. Okay, it's not the best solution. It just only beat 26%, but however, we are only focusing on the pre-order, in order, and stuff like that. So let's just see. Let's just try to describe what we did here. So let's just take this one. So first, with this helper function, okay, this helper function starts, and we have left and right. Will left will equals so basically here left will equals 0 at the beginning, and right will equals nums on the length. So 1 2 3 4 5, it will equals 4. And we have the mid equals 2. Yeah, mid equals 2. And we have this, all the variables that we have actually, and we have something, a variable called root, and it will equals this, it will be instance of this object, and it will be for this one, it will be have a value of I will say that it will have a value of it's the mid, which is b0. Okay, so we start by defining mid. We have 0, and after that we call the left side the right side. This is how we do the pre-order. We just the node, the left, the right. So basically we'll say that we have this node which is 0, and after that we start to adding all of the left. So basically the left, we add the left side which is will be left will be 0, and we add mid minus 1, which will be mid minus 1 will be 3. So basically when we call the left here, we call the helper function again. So basically the helper function, it will be the that we have left and right. So basically here is left still 0, but right it is mid minus 2, so it will be 1. And mid, it will be 0, but multiply, and the mid will be 0, I guess, also. And we will say if left bigger than right. No, left is not bigger than right. Okay, so continue to loop. Basically we have the root, we are creating a new tree node. The tree node will equals minus 3, and we call we have this the node will be minus 3, and we'll try to find the left of minus 3 again if we have a left, and we try to find the right. If we don't find right, this one will be null. Basically it will be nothing, and we are returning the root. So basically we will start again. So basically we have this one, and we're just returning the left. The left is still 0, however the right will be also 0, so it will be 0, and the mid will be 1 minute. The left will be still left, yeah. The left the mid is 1, so 1 minus 1, the mid will be 0, and the left will be 0, and basically we will take the first element, because everything is 0. So this will be 0, and this will be 0, and also the mid will be 0. So basically we will have this one. It will be minus 10, basically, because we are getting the elements on the 0 index, basically. So it will be something like that. So this will be the root right now. It will be minus 9, and basically the root dot left, there's no root dot left and root dot right, so I'm only returning the root. And when I'm returning the root, we will just have to remember that the function, the helper function that was running on minus 3, for this node, was waiting for return this root. So it will be it will add basically the root left to it basically. So basically right now we just established the left side, and after that we continue on the right side. And I know that just describing the recursion function, it's all the time looks quite hard, but when you just try to break it down to and just try to break it down to small areas, I guess it will be easier. And that's it for today's video. And if you like my solution, just make sure to subscribe and thumbs up, and give me thumbs up, and turn on the notification bell so you will never miss a video.